Good. Welcome back. We've discussed the drawing of geometries and the location of your project in the previous videos, the videos that dealt with IESve, and we've also used the basic model viewer to also view the project. Next, we're going to be using a tool called Suncast, which on a basic level, it's a very basic part of the IES assessment, but it actually looks at the solar radiation exposure of a project. Um, what is nice about this can be undertaken before you've added much information. So at the moment, this project or this model only has the geometry. That that's the only aspect that really has been defined, that and the location. And that is one of the first assessments that you can do, which is helpful. You'll see that it really just talks about exposure there. It's limited, but it's a good start in there. So once you've defined your geometry, I assume, saved your project. I will save it again as well. Then you can click on the Suncast tool. You'll see that you now enter a whole new screen, and at the bottom there are a number of the models that you're using themselves, and then there's a tool called images and then analysis. We'll start with just images. It's very basic, and in the images section you can define a number of views that allows you to analyze the solar exposure that that space or that volume might have. Now, the nice thing is you can do this, again, I think you can do this in IES, in SketchUp and Revit quite easily, or in the other modeling programs you have, because if you have defined the location correctly, but here you can also do simple analysis in terms of understanding what the massing impact could be on the exposure. You see that you can develop a single image, a timed image, which gives us an idea of how the sun moves along a space. I think it's quite helpful. Then there's also a fly around image. I don't think that's necessarily going to be helping you much. And then there's the sun view image. Again, the sun view image really gives you the view of the sun as it would be moving. I think it's informative. I don't think it's necessarily it's not something that you can't, it's not critical, if I could say it in that way, for you to analyze if you have the others. So if you use a single image, I think it's quite simple. You define a day in the year. So let's take the a simple equinox period, even 21st of March, and you can decide, well, let's see, I'm interested to see what will happen with that space or building at 9 o'clock in the morning. Okay, so you define the time. Then you can define the altitude and azimuth. Now remember that from our second year, you remember that the azimuth actually defines your position. It's often used in sun path diagrams. So that we say 0 would be considered north, 180 would be southern view, and then set 90 and to 70 degrees would then be east and west. So 140 therefore can be defined as a effectively a southeastern view. So if you would like to know what happens on the northern side, let's say the northeastern view, you can go for a 45-degree azimuth. The altitude again also talks about the height above the horizon. 40 degrees is generally good, 90 degrees is from right above. Again, you define that, and if you press the little plus, then you've got the view. So that's what happens at 9 o'clock. And, and here you can now you can play around. You can say, well, what happens at 2 o'clock? And you can add the 2 o'clock image, and you can see, okay, now that's what we're seeing at 2 o'clock in the afternoon when the sun is really on the western side of that. Again, if you change the altitude to 90 degrees, just so you see what it means. 90 degrees means you're really viewing it from right above, so it's not always beneficial to use that view. What you see is you generate a series of views are generated, and these you can then export. The timed view, I think is possibly the most powerful in terms of the shading analysis that you can use. Here you can actually say, okay, let's consider the exposure that that space might have. Now remember, this building has 0 shading devices on, so it doesn't tell us much yet, but you can add more detail. And we can say, okay, let's see what happens in June. Um, and we can say, let's view it from 5 o'clock in the morning till 7 o'clock at night. And we want to see if we are located, this is the current view, if we're viewing it from this point, what's the sun and the shading devices doing at every 60 minutes? And there you can change it. You can go for 5-minute intervals as well. Maybe you would like to do maybe 30-minute intervals. You can then choose to do two things. You can then create the images, which you'll see here. So this is all now on the same day. At 5 o'clock, there's nothing. At 5:30, there's still very little. At 6:30, and then at 7. So we know that the sun rises in winter in Tshwane a little bit later. Um, and so you go through it. And one could then move along, and it becomes, again, it's a very simple building. It doesn't tell you much yet, but you can, and that could then be adjusted for whatever spaces you've got. You can also choose to create a video where you would then make the video, and you can actually define the seconds, how many seconds per frame, and you put it together, and there you go. There you've got your time series of what it does. It actually builds that from all the images that you've now defined in here. So you might actually say, wait a minute, this is not important. You delete all those that are not important, and you build a video of that which you now put together effectively. And there you go. You've got it. Okay, so you're welcome to. I'm not going to go into detail with the rest. It's actually quite simple. It follows the same approach, except that the sun view image just follows the sun path. But again, you can develop a bunch of videos. You can save that in the end, or you can export the videos. A good analysis of the of the solar exposure. In the next video, we'll quickly undertake an important step, which is the Suncast analysis, which really looks at the amount of exposure that the surfaces have in its current location. So I'll pause the video and then start again when we're at that point. Good, so welcome back. We've just discussed the images and videos you can create from the shading analysis, and again, I think that can be a powerful tool if you've got a selection of buildings, courtyards, and so forth that you're analyzing. Next, we're going to do the Suncast analysis. Here, you'll see that you can do two things. You can look at the solar energy analysis, which really looks at the amount of kilowatt hours actually that you're exposed, that surface is exposed to, and the next would actually look at the amount of infrared infrared energy that it is exposed, that surface is exposed. Again, it's a single simulation that's undertaken, and ultimately it then gets it can be analyzed through both the solar exposure analysis and the solar energy analysis. It's effectively the same analysis. So first of all, you can see here that our weather file is correctly defined. Next, you can choose to model it for a single day or a single month or a data range. Best is to do a full year analysis, and the reason for that is you need to have a Suncast analysis to undertake any thermal analysis in the project in the Apache tool. So, and it will simply just reference this. So ultimately, just choose a full year. I think you can choose to calculate diffuse save shading factors. It's possible. It can have an impact if the surrounding environment is defined. And then you can also define a resolution in it. So you can say that you'd like to have it on a grid in the building, which I think is a nice way to view it. So once you've defined it, you simply state simulate. You'll see it defines the grid, and we'll start with the analysis. This should be quite quick, so there's no reason to pause it. But I'll pause it, and then you'll join us again when we've completed it. Okay, good. So now we've completed, and you'll see you get a little message at the bottom. It says solar analysis complete. You can state the load results. I find it's easier to simply click on load results there. It loads all of that. You'll note that because I've defined it on a 1 meter grid, which is not critical for your Apache analyses, it does take longer to do all the loading and so forth. It's just so if you're not going to use the Suncast tool extensively, then you can choose to simply untick that high resolution grid. As you can see, it takes a bit of time to now load it onto the model itself. I will let it load, and you can join again once I'll start the video again once it's loaded. Okay, so welcome back. It's now loaded the grid, and I then said I'd like to see any quantities above 0 kilowatt hours per square meter. You can obviously increase that when you're looking for a specific amount, or you'd like to understand the potential above a certain amount. And then in the end, you see that the range at the moment, we've got the full year analysis, so you can simply just choose that, but you can also choose just a single month in the end. Okay, so you press apply, and ultimately it then applies it to the model. So now we can toggle around this, and you'll see that it now gives me, and this is back in that model space, the model viewer, if you remember. And you can see here, it gives us an understanding of, over the full year, how many kilowatt hours per square meter exposure do we see here. And we see here that the maximum amount is 2036. So it's above 2000 kilowatt hours per square meter for that full year. That's a lot of energy. And you'll see that that's where the most of the energy lies. The rest of the energy then is much less. Well, it's still 1,400 and higher for north, and then as you go east and west, and then southern to the south, you see it's much less. So again, I think a nice analysis that in a more complex building, when you start working with geometries, and again, this is a question of what you're assessing. If you are concerned about overshadowing, or where's the best position for PV cells, for instance, you might simply just model the rough geometry and then use this in the end to define it. But as you can see, so here we can then view it, and it's again useful for analysis purposes. Should you want to look at the hours of exposure, that's the solar exposure. And again, here you can't define, or well, you can, I suppose you can define the minimum hours again, but again, you can load it, and as you can see now, we should be able to see here. Okay, these are the surfaces in terms of how much exposure they get to sunlight. So we can see again, and there's a clear correlation, but it makes absolutely sense. You'll see the top of the roof gets about 4,300, and then as you would go down, you start seeing less direct exposure 2,100 hours per year, and there you go. You see, even the southern side gets a little bit of sunlight, about should be about 440 hours of exposure per year. So it's not nothing in the end. Again, you can use it to model it and view it, and then obviously if you want to, you can say, okay, well, let's then start being, if we're concerned about the exposure, let's look for all the surfaces above 1,000 hours per year, and it actually adjusts the legend in the end. So so again, the exposure that you should be able to see. I think useful. I think the most use is in the end the kilowatt hours that you can view, and ultimately you would like to save this. There you go, you've saved it now, and that's important because this is what you'll be using in your Apache Sim simulation analysis in the end. Is that exposure and amount of sunlight that it gets becomes important in the analysis. Okay, so this is a longer video in terms of the Suncast tool, but I think you're welcome to also look at it. There's some few other little tools and so forth, but the principal tools are that you can do a shading analysis that's rigorous and that you know is accurate, and then also consider the exposure of the surfaces in terms of how much insolation they get, or direct sunlight, shortwave radiation, whatever you would like to call it in the end, which ultimately is important for your analysis. That's coming next. Good, thank you.